I've been a professor in the Department of Atmospheric Science here at Colorado State University for about 15 years, and it's been my privilege to serve as the head of the department for about the last 5 years. So in my position, I get to look at broad aspects of the program. So let me tell you about our program, in particular our graduate program. First of all, our department has been in existence for 41 years, and we're a program of research and scholarly excellence at Colorado State University. One of the very few departments on campus to enjoy that designation as a department. Our mission is pretty simple. We focus on two things. We focus on graduate education, and we focus on doing cutting-edge atmospheric research. And those things are actually one large focus, if you like. Our students are integral parts of our research effort here at CSU. We train our students to be researchers. Let me tell you about our graduate degree program in terms of some statistics. First of all, our faculty are all dedicated towards teaching graduate students, both in the classroom and in the research arena. To date, we've graduated about 550 master's students and over 200 Ph.D.s in the department's 42-year history perhaps now. We produce about 10 Ph.D.s per year, 15 masters per year. Where do these students go? Where do they get jobs, you might ask? One statistic that we're very proud of is the fact that we have almost 50 of our Ph.D.s are occupying tenure-track faculty slots around the world. We think this is an indication of a very strong program. We're placing our graduates in academic faculty positions. Also, we've had a number of our graduates that have achieved leadership positions at national labs. For example, National Severe Storms Laboratory, the Geophysical Fluids Dynamics Laboratory at Princeton have all been led by Ph.D. graduates from our department. We're very, very proud of that. Our education philosophy in the classroom, for example, is to provide breadth in the fundamentals of our science and then let the students take in-depth specialized courses in their field of choice within atmospheric science. Recognizing atmospheric science is very much an interdisciplinary program. So because of that, where do our students come? Where do our applicants come from in terms of their undergraduate degrees? Well, they come from a variety of scientific disciplines. Almost half of our students that come to our department have undergraduate degrees in atmospheric science or meteorology. The other half come from math, physics, engineering, and other scientific disciplines. So we have a very, very diverse, broad group of students that come in. We bring in about 25 students per year that enter our program. It's fairly small. At any one time, we have about 90 graduate students in our program. But because we don't have an undergraduate program by design, we focus all of our energies, if you like, on the graduate degree program. And I think the program here is very, very strong. It's very exciting for the students. One measure of that is the fact that students don't leave our program. They come here and they complete their master's or Ph.D. degrees. Our dropout rate is essentially immeasurable. It's about roughly 0% over the last 10 years. Yes, every once in a while a student may leave our program, but it is very, very rare. Our faculty are all known nationally and internationally. You will meet them. You will find out that they will be a very, very dynamic, stimulating group, both in the classroom and in the research environment. And you will find that they will give you their undivided attention and direct their energies towards helping you complete your degree program. Our department is very, very strong in a variety of research arenas. How I like to describe our program is that we have some of the very, very best tools to study the atmosphere. And these tools include observational tools, including radars and satellites and other cutting-edge instrumentation. We have a multitude of models in the department. We have models that simulate the detailed formation of tornadoes all the way through the large-scale flow and climate change on the global scale. These models, you will work with these models both in the classroom and in the research arena. And underpinning these models and the observational tools is the theory of how the atmosphere works. So in the classroom and in your research, you'll be exposed to these cutting-edge tools, both the models, the observational tools, and the theory. And you will address all the various scales in the atmosphere that we deal with. The atmospheric sciences deals with very minute particles, as you know, when small particles form in clouds, to the global scale. So there's many, many orders of magnitude that we deal with in terms of length scales in atmospheric science. And our program is basically set up to cover all these from a theoretical, modeling, and observational perspective. And just in closing, I'll mention a few of the large observational programs we have. The department, its roots are in tropical meteorology and also in observing the tropics, if you like. But we've grown from that, but we have a strong heritage and still a very strong program in observational meteorology. We have some of the very, very best satellite meteorologists here in our faculty. We have a very, very strong program in radar meteorology. We host the only very large cutting-edge weather research radar at any university in the United States. When you combine these observational tools with the models and, as I said, the theory, our students really do get a very, very broad education. And we know that the education they get here serves them well through their career because we can track our graduates and see them be very, very successful. And it's our pleasure to be a part of that. Our students come here, they're the lifeblood of what we do. They're the excitement. They come and they move on, and as faculty and staff in our department, we get to reap the benefit of that by seeing them mature into researchers and then go on to lead the field. And we're very proud of that.